How exactly does a seatbelt save lives? In this video, we're going to learn about the forces acting on an object due to changes in momentum. You may find it useful to brush up on momentum by watching this video. All moving objects have momentum. A stationary object has a momentum of 0. We calculate momentum using this equation. Momentum P equals mass m times velocity v. So what are the units of momentum? Mass is measured in kilograms and velocity in meters per second. So momentum equals kilograms times meters per second, which equals kilogram meters per second. Now try this example. What is the momentum of a 100 kilogram ostrich travelling at 8 meters per second? Pause the video while you work it out. How did you do? Rapid changes in momentum can be extremely dangerous. Can you think of examples of rapid changes in momentum? During a car crash, the momentum of the passengers decreases rapidly from a large number to 0 in less than a second. This places huge forces on them, which can be lethal or cause serious injury. We can calculate the force acting on the passengers using this equation. Force equals change in momentum divided by time of change. Where the force is measured in newtons, momentum is measured in kilogram meters per second, and time is measured in seconds. Let's try this example. So our 100 kilogram ostrich is travelling at 8 meters per second. What forces require to stop it in 5 seconds? First, we need to calculate the change in momentum. Momentum at start equals mass m times velocity v, which equals 100 kilograms times 8 meters per second, which equals 800 kilogram meters per second. Momentum at end equals 0. Change in momentum equals 800 minus 0, which equals 800 kilogram meters per second. Now we need to substitute these values into our equation. Force equals change in momentum over change in time, which equals 800 kilogram meters per second divided by 5 seconds, which equals 160 newtons. That's a lot of force. Imagine a person with a mass of 70 kilograms is travelling in a car at 15 meters per second. The car comes to a complete stop in 1 second. What's the force acting on the person? Pause the video while you work it out. That force acting on a person could be fatal. Rapid changes in momentum create huge force that are dangerous. Car manufacturers use crash test dummies to study the forces the body is subjected to in various crash situations. We can make changes in momentum less dangerous if the change happens over a longer period of time. With no seatbelt, the body will move forwards and come to rest rapidly as the person hits the stationary parts of the car. A seatbelt stops the driver from being thrown from the car and allows a longer time to slow the body down by locking and then stretching during the crash. Seatbelts, airbags and crumple zones all reduce the force by increasing the time over which the change takes place. So now you can see how a seatbelt can save your life.